Using humus on golf course fairways to alleviate soil salinity problems by Zhu and Lee. This was published in Hort Technology in 2018. The introduction is basically straightforward. He's saying that turfgrass is widely used. Much turfgrass is actually being irrigated with reclaimed water that can be high in salts, high in sodium. More and more golf courses are using reclaimed water rather than potable water as a means to basically get rid of effluent water that's generated from our wastewater treatment facilities. The study was conducted from 2015 to 2017 on 2 golf courses. During 2015 and 16, the study was on the 17th fairway of Valley Country Club in Aurora, Colorado. The fairway was covered with primarily Kentucky bluegrass, and the area was aerified prior to each year or whatever. Recycled water from the local water treatment plant was used for the irrigation in Colorado. Okay. I'm going to show that in a second. During 2016-2017, another study was on the first fairway of Bully Pulpit Golf Course in Medora, North Dakota. The fairway was covered, again, primarily with Kentucky bluegrass. And let's go to the next. So the 2 study sites followed the same research protocol. Treatments included top dressing with sand plus reed sedge peat at 90-10 by volume, top dressing with sand and reed sedge peat at 80-20 by volume, or spraying humic substances from Dakota peat. Now, this was a humic acid derived from peat, not from leonardite, which is probably what most people are more used to. And the sprayable humic acid was applied at either 1 gallon or 3 gallons per acre, and there was a non-treated control. All right. And they measured a number of things. NDVI, they measured turf quality, on a 1 to 9 scale, with 6 being the minimum acceptable limit. Let's go to the actual soil and water variables that they measured. You'll see here in Colorado, the EC was a little bit less than our critical limit sort of for salt levels in the soil. It was around 1, whereas in North Dakota, we're talking about 3 or 3.3, moving upwards in the areas of high risk for salt problems with turf grasses. And the irrigation water in Colorado was also around 1. But the salt water the effluent water in North Dakota was 2.4 in salt. So the water in North Dakota was much worse in terms of its quality than the water being applied in Colorado. You can see the pHs were 7.8 in Colorado and around the same, 7.6 in North Dakota. The sodium levels in North Dakota were 660 parts per million, whereas in Colorado was 148 parts per million. So you can see that very likely there's some salt issues in North Dakota, as well as potentially some sodium issues in North Dakota. Colorado could be the same thing, but it's a little less pronounced in the Colorado location for this study. Now we go to the results. The results I'm going to show in these tables, the turf quality, the summary is basically the humic acid applied at 3 gallons per acre resulted in as good or better quality than any other treatments, including the control or just top dressing with straight sand in May, June, July, August, and September. The sand and peat treatments oftentimes had a similar quality as the humic acid applied at 3 gallons, and the humic acid applied at 1 gallon did not result in the equivalent quality as the humic acid applied at 3 gallons per acre. So there seemed to be a benefit in terms of turf quality from applying the humic acid at 3 gallons relative to 1. But the same benefit was generally observed from the sand peat applied at 80-20. So in this case, if I were consulting, I would ask which one of these 2 options is the least expensive, because they're more or less resulting in the same response, and we'd want to use whichever one is most cost effective. The NDVI supported the results from the quality. So the NDVI from humic acid applied at 3 gallons per acre was the greatest, equal to or greater than any other treatment, with some of the sand peat 80-20 NDVI values being equivalent to the humic acid. So humic acid applied at 3 gallons seemed to be beneficial in the Colorado setting. In the North Dakota setting, it was similar. Humic acid applied at 3 gallons generally resulted in the highest quality ratings, but not always, but generally. For example, the sand peat 80-20 was equivalent to the humic acid at 3 gallons per acre, again, in the North Dakota location. NDVI was, again, similar to the quality, where we see the NDVI from the sand peat 80-20 being comparable to the humic acid at 3 gallons per acre, but both of them being superior to just control or just applying top dressing with pure sand. So we're going to go to the conclusion in just a minute. The soil properties, generally speaking, the soil properties weren't greatly affected by the humic acid 3 gallon application where you'll see occasionally there'll be a reduction in pH, or occasionally there might be a change in soil, the electrical conductivity, but generally you'll see things like the salinity was the same compared to the control, There's a little bit of a reduction here in September where the application of humic acid applied to 3 gallons reduced the salinity a little bit. The infiltration rate generally was not affected at all by the application of humic acids. It was more affected by the sand-containing treatments. The bulk density, again, wasn't really consistently affected by the humic acid treatments where they were the same as the control. But generally, the sand-containing treatments did, at least the sand 80-20, did result in a reduction in bulk density. The organic matter didn't change as a result of the application of humic acids, but generally did when the application, following the top dressing that contained sand. There was a little bit of an increase in the microbial biomass carbon using humic acids or any of the humic-containing products, including the sand peat, compared to doing nothing or compared to doing sand in the Colorado location. And generally the same thing occurred in the North Dakota in terms of the soil changes or soil properties, where the humic acid applied at 3 gallons didn't do a whole lot here and there. Occasionally there would be a blip on the radar, but generally it was the sand-containing treatments that resulted in a reduction in electrical conductivity, or electrical conductivity. It looked like there was actually a slight. There was a slight increase using the sand in North Dakota, but there wasn't a change in electrical conductivity using the humic acid. The infiltration rate, again, was increased using sand, but not with using humic acid. The bulk density generally wasn't that much affected with humic acid, but the microbial biomass carbon was affected by all the humus-containing treatments, including the sand peat treatments. Okay, so humic acid seemed to have an influence at the 3 gallon, not so much at the 1 gallon rate. The conclusions were, the results showed that the application of humus increased the soil microbial biomass carbon and improved turfgrass quality over the untreated soils on 2 fairways that had either inherent soil salinity problems or was irrigated with recycled water with high salt content. So under this setting in North Dakota or in Colorado with high salt and probably a little bit elevated sodium as well, the application of humus products such as humic acid and including the sand peat treatments as well did result in an increase in turf quality and an increase in microbial biomass carbon. So under these settings, there may be a benefit to using a humus or humic containing product when you're in high salt content soils with turfgrass. If you want the long form version of this video, I'll link it above. Thank you.